Hi, hello, this is Giri, teaching 10th Mathematics, the chapter sets. Here is the key concepts from the chapter, and this is part 5 video. In this video, we will learn what is meant by equal sets and what is meant by equivalent sets and the fundamental theorem on sets. Dear children, here are some key concepts. The first is equivalent sets. When can I say that the two sets are equivalent? If two sets have the same number of elements, then they are said to be equivalent sets. I shall repeat. If two sets have the same number of elements, then they are called equivalent sets. For example, A is equal to set 1, 2, 3 and B is equal to set x, y, z. Here number of elements in set A is 3 and number of elements in set B is also 3. Here, even though the elements are not equal, even though the elements are not same, but the number of elements of set A and set B are equal. You can see here, the total number of elements in set A is equal to 3 and the number of elements in B is equal to 3 again. Therefore, both the sets A and B have the same number of elements, then both the sets are called equivalent sets. And equivalent sets can be represented by the symbol. A and B are equivalent sets. Or you can read this as set A is equivalent to set B. Equivalent means the number of elements are equal. Now the second type of sets is equal sets. If two sets have the same or equal elements, then they are said to be equal sets. If two sets have the same elements or equal elements, then they are called equal sets. For example, A is equal to set 1, 2, 3 and B is also equal to set 1, 2, 3. If you observe both the sets A and B, every element of A is also equal to element of B. 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. Therefore, each element of set A is equal to each element of B. That is, the elements are same in both A and B. The number of elements is same and the elements are also same. In such case, you can call both the sets A and B as equal sets. If A and B are equal sets, then you can write A is equal to B. A is equal to B means A and B, both the sets are equal. If both the sets are equal, then their elements are equal. Now, can you distinguish between equivalent sets and equal sets? Dear students, you see here, equivalent sets means the number of elements in both the sets are equal. The number of elements. The elements need not be equal, but the number of elements should be same. Here, if you look at the first example, A is equal to set 1, 2, 3 and B is equal to set x, y, z. The number of elements in set A, how many elements are there in set A? 1, 2, 3. There are 3 elements in set A. And how many elements are there in set B? 1, 2, 3. Again, there are 3 elements in B. Since the number of elements in both the sets A and B are equal, then both the sets are called equivalent sets. Then when can I say that the two sets are equal? Two sets are said to be equal if their elements are same. The elements should be same. In the other case, the elements are not equal in equivalent sets, but whereas in equal sets, the elements are also same. In such case, you can say that both the sets are equal sets. Now the next is fundamental theorem on sets. It states that if A and B are any two sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. I shall repeat. If A and B are any two sets, then number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. This is called fundamental theorem on sets. I shall repeat. If A and B are any two sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. Now let us solve a simple question basing on this formula. Find n of A union B if n of A is equal to 4 and n of B is equal to 3 and n of A intersection B is equal to 2. Here, in order to solve this, let us write the formula first. N of A union B is equal to N of A plus N of B minus N of A intersection B. Now substitute the known values. N of A is 4 plus N of B is 3 minus N of A intersection B is 2. 4 plus 3 is 7 and 7 minus 2 is 5. Therefore, N of A union B is equal to 5. If you observe this equation, there are 4 different values. One value is N of A union B, second value is N of A, third value is N of B, and fourth value is N of A intersection B. Out of all the 4 values, if you know any 3 values, then you can calculate the fourth value using this formula. This is called fundamental theorem on sets. Next, disjoint sets. When can you say that the 2 sets are disjoint? The name itself indicates disjoint, means there is no joint. There is no joint means there is no common element. Okay, understood? If 2 sets have no common elements, if 2 sets have no common elements, then they are called disjoint sets. Understood? For example, you look at this example. A is equal to set 1, 2 and B is equal to set 3, 4, 5. Is there any common element in between the sets A and B? Here, if you observe the sets A and B, there is no common element in between both the sets A and B. Since there is no common element, then both the sets are called disjoint sets. There is no joint means there is no common element. Okay, if A and B are disjoint sets, then what will happen if you find A intersection B? Here in this case, for example, we take this case only. A is equal to set 1, 2 and B is equal to set 3, 4, 5. If you find intersection means you have to list out the common elements. Any more common elements? No common element is there, therefore it is an empty set. Therefore, if A and B are disjoint sets, then A intersection B is equal to 5. And its converse is also true. That is, if A intersection B is equal to 5, then A and B are called disjoint sets. Is it clear now? Now, if A intersection B is equal to 5, then what is N of A intersection B? Means how many elements will be there in A intersection B? Since A intersection B is an empty set, the number of elements in A intersection B is 0. Now, N of A intersection B is equal to 0. If N of A intersection B is equal to 0, if you substitute N of A intersection B is 0 in this case, then what about N of A union B? N of A union B is equal to N of A plus N of B. Here, these are the 3 important bits or important concepts you can say. The first one is, if A and B are disjoint sets, then A intersection B is equal to 5. And the second one, if A intersection B is equal to 5, then A and B are disjoint sets. And one more point, if A and B are disjoint sets, then N of A intersection B is equal to 0. N of A intersection B means the number of elements in A intersection B. Since A intersection B is 5, number of A intersection B is 0. Now again one more point, if A and B are disjoint sets, then N of A union B is equal to N of A plus N of B only, because this is 0. Clear? Dear students, look here please. If A and B are disjoint sets, then what is N of A union B? If they are disjoint, then we know that N of A intersection B is 0. If this is 0, then what about N of A union B? N of A union B is equal to N of A plus N of B. That is the fourth point you should note down regarding disjoint sets. Thank you one and all.